So when we're going to open this valve, we're going to open it very slowly and easily. And we're going to do it as far away as we can, which is a full arm's length away, right? And we're going to face away from it, right? Like this. We don't need to look at this needle. We can look at that later. We're going to do it like this, right? We're going to look up at the sky. It's a beautiful blue sky, yes.
I see some dark in that cloud.
So we don't want to be on this side, okay? You don't want to do this. I want to be over here like this. Certainly don't want to be doing this. Because what we're worried about is we're worried about something called regulator burnout, RBO. Do you know what the triangle of combustion is?
Yes.
Okay. And do you remember what the three things are that you need?
Oxygen,
fuel, and heat.
Yeah, heat.
Right? You need a heat source. So if we have oxygen by itself, right? That's not a problem. There's oxygen in the air we're breathing right now, otherwise we'd be dead. And if you have fuel by itself, that's not necessarily a problem. But of course, if we just let the acetylene out of the bottle there into the atmosphere, there's oxygen already in the atmosphere. So we've got something going there.
Light a match.
So if we had, and what's the match? The match is the heat. It's the ignition source, right? So the idea is you're going to have all three. Well, there is a phenomenon called I think it's called the heat of recompression or something like that. I don't remember the technical mumbo jumbo, but all you need to remember is this. If there is pressure inside here already, like say the last person who used this, let's say they came and they shut this off, okay, and then they close this valve, there would be pressure still in here, okay? And then you come along, and if you open this valve quickly, you'll suddenly let that genie in the bottle, that tremendous amount of pressure, rush in to here.
Yeah.
And you've already got pressure in there. So what you end up with is inside here, you end up with a spike in pressure. Not to get too technical, but there was this dude a while back, his name was Boyle, and he has this thing called Boyle's Law. And he figured out that when you have a closed volume, that there's a direct relationship between temperature, pressure, and volume, okay? And if you have volume the same, but you increase pressure, temperature has to go up. If you increase the pressure really quickly, the temperature in here will spike. Pressure spike, temperature spike. If you have any contaminants in here, dirt, debris, anything that could act as a very small amount of fuel, and that pressure spikes, now you've got all three parts of your combustion triangle, and you can literally have a fire starting here. That could actually get so hot, it could start to melt the internal components of the regulator. And those internal components of the regulator, if they get hot enough, they'll actually burn. They'll become a fuel. On aluminum regulators, that happens at a much lower temperature. So aluminum becomes a fuel at a much lower temperature than...
Is that what you have?
No, this is brass. Remember what we saw in that safety video about the firefighters in there, right? The majority of those little cylinders they carry around, they're using aluminum regulators apparently, which I didn't even know. But anyways, this is brass, so this is better. But it doesn't matter if all of the components in here start to melt. Well, the way this regulator works and everything, I'm pretty sure that once those parts start melting, what happens? It no longer does its job.
Yeah,
so now the genie in the bottle starts coming out even faster. So now you've got a fire in here accompanied by a loss of control of the pressure. So the pressure starts to go even crazier. So you end up with a huge fireball coming out of here. Meanwhile, all of that oxygen that comes out of here, if you're standing anywhere near this, all of that oxygen gets all on your clothes and everything, and then you get caught on fire, and you have not just your clothes burning, but you have oxygen-saturated clothing that's burning, okay? And you end up with really bad burns all over your torso, your face, your hands, your arms. I mean, it could be really bad. So we want to avoid RBO, regulator burnout. So that's why we're going to open this up. We're going to crack this open really slowly and easily. Once we open this valve, because this is a high pressure cylinder, okay, this type of valve is called a backseat valve. The way the packing works in here is it's designed to be fully sealed and off and keep things from leaking out of this stem right here when it's all the way closed and when it's all the way open. So you don't open this halfway and leave it, because then you could have run the risk of leakage around here where the stem is. So this is a backseat valve. So when we open it up and we crack it, once we're satisfied everything's kosher and safe, we open it all the way up. This valve on the acetylene, because this is not a high pressure tank, this valve, we only need to open it far enough so that we can get a reading.
Mm-hmm.
So typically you can open this half a turn. Sometimes a half a turn's not quite enough, but you're never going to want to open this more than a full turn. So a half to 3/4 usually will suffice. And the reason why we do that is to make sure that if something goes wrong, we want to have a pretty decent chance of being able to come over here and shut this valve off and shut the fuel off.
Mm-hmm.
Okay? And that's a judgment call, obviously. You see a little tiny flame coming out over here. I don't want you doing it. I don't want you running away. Okay? But I'm going to come over here, my gloves, and I'm probably going to try and shut this off. Or I'm going to grab fire extinguisher or hose and try and extinguish that flame and then shut this off. Okay? But we see a flame coming out, shooting out this tall. Okay? We're both running for our lives. That's it. Seriously.
Yeah.
All right? All right, so I've hooked up the hoses. Of course, you always want to inspect your hoses, make sure they're in good shape. You know, if you bend the hoses and you see all cracks in the outside jacket and everything like that, that means that, you know, they're in bad shape. I've got the regulators backed off all the way. These are loose, okay? I'm going to open the gas valve. So how am I supposed to do that? You remember what I said?
Extend it and looking away.
Okay, and am I going to crack it fast or slow?
Slow if you want to.
I mean, if I want to. Come on.
Slow.
Safety's serious, right? All right. And I back it unscrew it all the way till it stops.
Yeah.
Fully backed out, right? Because this is a backseat valve like we were talking about. All right, so now I look at my gauge. Oh, wow.
Empty?
Well, no, there's some in there, but we're low. Hopefully my other tank's got oxygen in it. If not, we're off to the welding supply store. All right, so now we come over to the fuel. What do they say about the fuel? How do we open the fuel?
Half a slow, half a turn.
Right. So that's about a half turn right there.
You got some pressure on it.
And we got plenty of acetylene. So, all right. So the next thing we got to do is we've got to set our regulators to the proper amount for oxygen and acetylene. How do we determine what to set these at? Or you have a book or a chart that you can consult depending on what we're going to use for a torch, so for an attachment. So let's talk about that. This is the torch body, right? Okay. Got my hoses hooked up here, right? And again, you know, green is for oxygen, red is for fuel.
Yeah, fuel.
Okay. See these things right here? These are extra things I added on. I bought these and added them on, okay? These are called check valves. And what this is for is, this is to stop the possibility of flame coming back down the hoses and actually causing a fire inside here in your hoses, and even possibly going all the way back to the regulators. For instance, when the oxygen tank starts running really low and the pressure drops, okay, there's a possibility that the flame could try and chase up back up the hose. Okay, that's what these are here for. So these are a good investment in my opinion. A lot of people don't bother getting them. These are about, the good brand name ones like this, they're about $40 for a pair. So this is the body, right? But then on the body, we have this right here. See how that looks?
Yeah.
That's called a rosebud, because when it's burning, it makes a pretty little, like, flower shape, I guess, or something is the best way to describe it. Okay, this is just for heating. And it's like the only reason that I still use this oxyacetylene setup is occasionally I need to heat something, either like a frozen bolt or a nut. This is like really good for getting frozen nuts and bolts out, okay? Or if I'm gonna weld a casting, lots of times I want to preheat that casting and bring it up to temperature, bring it up to like 600 degrees, and I'll do that with this. Okay, so that's why I have this on here now. So let's take that off. So there's three basic types of tips or attachments that we use on this. A Rosebud like this for heating, welding, brazing, or soldering tips that are going to look like this. Okay. This is a cutting torch attachment. Okay. Cutting torch attachment has its own special tips, and we can put different sizes in here. With these types of torches, we get a pinpointed flame. With this, if you look at this,
There's like 5 of them in there.
you can actually see there's like,
6 or 5.
well, if you look closely, you'll see that one's dirty, but you can see that there's a large hole in the middle. Here's one that's clean. See, there's a large hole in the middle surrounded by a series of small holes. Unlike this, where you have one flame coming out of here.
Yeah.
Okay. With this, you get a whole bunch of
7.
little flames in a circle. Okay. And then, you see this lever on the side
Yeah.
here? When you hit this lever, it gives you an extra burst of oxygen through that center one,
Yeah.
and it creates that cutting flame.
Mm-hmm.
Okay, so these ones going around the perimeter here, they act to preheat the metal, and then when you're ready to cut, you hit that lever and it'll cut. So we'll cover that when we get to using the cutting torch. Getting back to our torches, how do you determine the settings on the regulators for the torch? You go by the size of the hole, right, the size of the torch. Now sometimes you're lucky and it's clearly marked. If you look on this one, you see there's a 0
Yeah.
right there. So this is a size 0 torch, and this is a Victor. This is the brand name, right? So I already went online and I pull up a chart, and you can get booklets that will show you all of this stuff. The PDF file I downloaded. So we look under, you see up here it says acetylene,
Yeah.
right? Cutting tip chart, all right? Well, we're not using the cutting tip, right? We're using welding. So we come down to welding nozzle flow data, and we look at a tip size 0.
Yeah.
So the first thing we look at is, what is a tip size 0 for? If you look to the left, it tells you metal thickness, 1/32 of an inch to 5/64 of an inch. So you would never want to use this tip on like trying to fusion weld 1/2 inch steel, because you'd be there all day trying to get it to develop a weld puddle. Now we go over to 0. Look what it says in this. Here's a column. It says drill size. Why did they give you a drill size?
So you can clean the hole.
No, you never want to use a drill to clean the hole. Because if you use a drill that's a little too large and you put it in there and you think, oh, I'll just turn it, you'll literally drill this hole larger. Now it's no longer what it was rated. It's no longer a 0. You've now enlarged the hole. You've turned it into a completely different torch that it's not even designed to be, by the way. So you don't want to ever do that. The reason why they give you a drill size is because a drill bit set is the closest thing to a gauge that just about anybody can get a hold of. A number 65 drill bit is 0.035 inches. That's 35 thousandths of an inch in diameter. That's what the size of this hole should be. If we didn't know what this was, if we didn't see that 0 on there, we would take our drill set and we would find the number 65 drill and we would see if it fits in here just right. We try maybe the next size up. The next size up shouldn't fit, and the next size down would be loose. So we want to make sure we get the right one. When you get into those number drills, those high numbers, because this is a very small torch for cutting thin, for welding thin metal, the drill bits are pretty small. You see the numbers?
Mm-hmm.
So this gold one right here happens to be the 65. So I'm going to pull this 65 out. Do you remember what it said the size of this was?
No.
0.035 or 35 thousandths. That's actually 34.5 thousandths. So we know that that's the right size drill. I know that I checked that because just in case accidentally the last time that drill bit was put away, if it was put in the wrong place, because you can't see a number on there, you can't tell if that's a 65. So now if I take this 65 drill bit, look at that, fits in there perfect. Now I know that that's a 0 torch, and if it's a different manufacturer, you might, you gotta look up on their website.
Yeah.
It's a Smith torch or whatever. This is a precision instrument that tin knockers shouldn't touch ever. Okay. Anyways, do you know why we're going to use this welding tip?
Previous welding pin stuff.
Because it's the only one I own. Seriously. I had a couple other ones, but I had another torch setup, one of those portable ones.
Yeah.
And I sold it, and I sold the other tips with that.
Get more money.
It's all about the Benjamins with you, isn't it?
With you.
Homie.
You should keep that on the video.
Oh, like the fingernails on the chalkboard, right? All right, so
love that noise.
we're going to go back to the chart. We're going to look at 0, and we go across, and what does it say? For oxygen, minimum pressure of 3
and
max of 5. And what's it say for acetylene? Minimum of 3, max of 5. So 3 and 5, 3 and 5.
4.
I like running the oxygen a little higher than the acetylene. So I suggest that we set it to 3 on the acetylene and 5 on the oxygen. Don't touch it, it's liable to explode, I tell you. So I'm going to turn this in now until we get a reading of 5 over here on this side. So this 20, that's 10, so 5's way down here. That's about 5 right there. See it?
Yeah.
Pretty low. But when I open this valve on the torch, it's going to go lower. See? So what I actually want to do is I actually want to have this open and then dial that up. So that looks pretty good. All right, so now I'm going to turn this in until this says 3. All right, so that's 3 right there. So go ahead and open that valve.
Towards or away?
Well, there's only one way you can turn it. It's clockwise, counterclockwise to open it. There you go. Go ahead, open it up. So gas is flowing, right?
Yeah.
It didn't drop that much, so just a little bit. That's good. All right, go ahead and shut it. So now we have our regulators set. What do we do next? Do you know?
We light it.
Next thing we're going to do, because we just did up all these connections and everything, is we're going to check for leaks. So to check for leaks, I have this stuff right here. It's called Snoop Liquid Leak Detector. Okay, that's got a cute little caricature of a dog, like a bloodhound, right? All right, so you can buy stuff like this, but if you don't have something like this, you can use water with a little bit of dishwashing liquid in it. So you get a soapy mixture. Bubbly mixture, exactly. And then what you do is you spray that onto your fittings, and if you see bubbles, you know you've got a leak. All right, so no leaks, that's good.